For hydrocarbons, we can draw two different types of structural formulas. One type is the expanded structural formula and the second type is the condensed structural formula. So let's take a simple example, methane. So if I draw the expanded structural formula for methane, I will show the four bonds in an expanded way like this. So I draw all four carbon-hydrogen bonds expanding the carbon-hydrogen bond, showing a dash in between the two atoms. So this is called expanded structural formula. So how can I convert this into a condensed structural formula? The condensed structural formula just shows the two types of atoms and the number of atoms for each of them. So there is one carbon atom. So I don't write the number 1 as a subscript in front of carbon. It's a known fact. And there are 4 hydrogen atoms. So I will write number 4 as a subscript. So this is called a condensed structural formula. So you can see here when you write in the condensed structural formulas, we can write it for different types of groups. For a CH3 group, the expanded structural formula is shown here. So you can condense it like this. Remember, when you condense the CH3, you still have to draw the bond showing, keeping the space for any attachments. And for a CH2 group, you can show the condensed structural formula like this. Okay, so there is another type of formula called line angle formulas. And also we call this as a skeletal formula because this formula just shows the lines without showing the atoms. And this is a zigzag line, in which the carbon atoms are represented as the ends of each line and as corners. What does it mean? So let me take a simple example. Let's say for the molecule ethane, which has 2 carbon atoms. So if I draw the line angle formula for ethane, it will be just like this. So what does this mean? So the corners of this line represent one carbon atom. So there are 2 corners, so there should be 2 carbon atoms. And if there is 2 carbon atoms, we need to know that there should be 6 hydrogen atoms. So the 6 hydrogen atoms will be placed like this. So that is how we can convert a line angle formula to an expanded structural formula. So now there is another molecule here. So you need to visualize the carbon and hydrogen atoms in here. So this is most of the time students get confused on how to number or how to count carbon atoms in this type of line angle formulas. So the best way to count is just keep placing the carbon atoms into the every corner and to the ends. So these are the 2 ends and these are the corners. So these are the 2 ends. So you need to make sure you keep a carbon atom to each corner and to the H's or N's. Now, remember the rule number one when it comes for hydrocarbons. Every carbon atom must have four bonds. Four bonds. So for each carbon atom here, now you see only one bond. So let me draw the other bonds. So you already see one bond. If I take this carbon atom, you already see one bond is there. So there should be three other bonds. So those three other bonds comes with hydrogens, right? And then in this carbon, it already has two bonds. So to make it four, there should be two other hydrogen atoms. The same here and same here and same here and same here. Actually, it's different. It's CH3 here because it has only or it has only one bond. So to make it four, we need to place three hydrogen atoms. So this is how you need to visualize when you see a line angle formula. And if you are given an expanded structural formula or a condensed structural formula, you should be able to convert it into a line angle formula too. Okay, let's do an example problem. Draw the expanded structural formula for pentane. So when it comes for these structural formulas, you need to pay attention to this term, whether it's an expanded, whether it's a condensed, or whether it's a line angle form. So this is an expanded. Expanded means you need to show the carbon-hydrogen bonds clearly. Okay? And the structural formula is for pentane. Now, given the name, as I mentioned before, you need to remember the prefixes versus the number of atoms. Now, this is for pent. Pent is for 5 carbon atoms. And it is an ane. Ane means it is an alkane. So alkanes only have single bonds. Only single bonds present. Because we will talk about alkenes and alkynes in future. They have double bonds and triple bonds respectively. But here we don't need to worry about double or triple bonds. It's just single bonds. So each carbon must have 4 bonds. So that's the rule we need to keep in mind. Now we can start. So for pentane, first you need to draw 5 carbon atoms. So let me give you the example here. Just like this, you need to draw 5 carbon atoms. That's the step 1. Now, the question is to draw the expanded structural formula. Now, you need to show in the next step, you need to show the carbon-hydrogen bonds clearly for each of these 5 carbon atoms. Let's see how does it looks like. Good. So this is the answer. So the expanded structural formula is given here. As you see, the name implies you need to show the expanded formula, expanding all the carbon-hydrogen bonds and carbon-carbon bonds, keeping a dashed line in between the atoms. And it is pentane, so there are 5 carbon atoms, and there should be 12 hydrogen atoms altogether. Okay, now draw the condensed structural formula for pentane for the same molecule. Now, for the condensed, you just need to convert those CH CH3s, you need to show as CH3, C carbon, hydrogen, then subscript 3. And for CH2s, you need to show it as carbon, hydrogen, and subscript 2. Let's look at the answer. So as you see here, you need to convert each CH3 into our CH3 in condensed and CH2s. There are 3 CH2 groups and last CH3 group. This is the condensed structural formula. And you can place this dashed line. And sometimes I have seen this is also correct. CH3, CH2, CH2, and CH3. If you see any of these formulas, both of them are considered as condensed structural formula. Okay, good. Now, draw the line angle formula for pentane for this to the same molecule. This will be a good question. Now, that is for pentane. So there should be 5 carbon atoms. So you need to show the place the 5 carbon atoms in a zigzag way. So what I would do is I would just put them like this: 1, 2, 3, 4, 5 in a zigzag way, and it is a pentane, which is an only carbon hydrogen single bonds and carbon carbon single bonds. So in the line angle formula, you just have to draw it as a zigzag line: 1, 2, 3, 4, 5. Okay, so that will be the pentane's line angle formula. Let's look at the answer. Yeah. So this is for the same thing that I just did. So I only added carbon atoms. So you can just convert the CH3s, CH2s, CH2s, and CH2s, and CH3s. So remember, the ends contain CH3s and the corners contain CH2s. So in simple form, like you can do what I just did. Like you already know, like there are 5 carbon atoms. And then you can convert this into the line angle structural formula.